In the last lectures, we discussed the dot product and its properties and implementations in the project lecture. In this lecture, we will define a new interesting mathematical operator, the cross product or the vector product. Let's take a look at the A and B, two non-zero vectors with angle theta between them. The cross product or the vector product between A and B is defined as A cross B, and the result is vector C, which is perpendicular or orthogonal to the plane spanned by A and B. The vector product can be written as C equals to A cross B, which is equal to the magnitude of A multiplied by the magnitude of B multiplied by sine theta multiplied by n, where the magnitude of A, the magnitude of P sine theta, is the magnitude of the vector C, and n is the unit vector in the C direction. There are two options for the direction of the vector C, up or down to the plane spanned by A and B. The direction of the vector is determined by the right-hand rule. The opposite of the vector A cross B is B cross A. Therefore, A cross B is equal to minus B cross A. The cross product between two orthogonal vectors is equal to a vector with magnitude of A multiplied by magnitude of B. And the A perpendicular direction for A and B, again, from the definition of the cross product, the sine of 90 degrees is equal to 1. From the definition of the vector product, we can conclude that the cross product for two parallel vectors is equal to 0, because the sign in the definition is equal to 0. Let's recap the unit vectors I, j, k. The three unit vectors are perpendicular one to another. The cross product, as we learned, between two perpendicular vectors is the vector perpendicular to both vectors. In this special case, the two vectors are unit vectors. Therefore, the magnitude of the third vector will be 1. The direction is defined by, if we start from I and we go and we do the cross product clockwise, we will get the third vector with the positive sign. If we go anti-clockwise or counterclockwise, we will get the third vector with negative sign. For example, the cross product between I and j is k. Between I and k is minus j. Here, as you can see, the order is matter, I, j, k. Now, let's take a look at the parallelogram with the two adjacent sides, the magnitude of A and magnitude of B vectors. The area of the parallelogram is the magnitude of the cross product between A and B. This is one of the important uses of the cross product. Now, if we look at the unit vector in the direction of C equals to A cross B, the unit vector is defined as the vector divided by its magnitude, as we learned before. Therefore, n is equal to the cross product between A and B divided by the magnitude of the cross product. Therefore, it's equal to A cross B divided by the magnitude of A multiplied by the magnitude of B multiplied by sine the angle between A and B. In the next lecture, we will compute the analytical expression of the cross product. That's it for now. We are reaching the advanced topics in vector algebra. Take a break and let's continue in the next lecture. See you there.